Hi everyone, now to one of my favourite parts of the mathematics course in high school. We're looking at the balancing method. Being able to do this well opens up all sorts of doors to maths, so it's quite important that we do it, and it stops us relying on guessing and checking as often. Now the balancing method's centred around one idea, that the left hand side of the equation needs to always equal the right hand side. If you do the same operation to both sides of an equation, the equation will remain true and the two sides will still equal each other. It doesn't matter what left-hand side or right-hand side is, as long as we do the same operation correctly, the right-hand side will stay equal to the left-hand side. Now, a good way of representing this is as follows. If we're adding to both sides, we will take the whole left-hand side and we'll just add it to the end. If we were subtracting from both sides, we would just subtract from the end. If we're multiplying both sides, we would do something that looks like distributive law. We'd stick the multiplication out the front and then multiply it through. And if we're dividing both sides, we divide the whole left-hand side by writing it as a fraction. Now, if we do this, it will avoid most of the errors that occur with the balancing method. So to actually perform the balancing method and solve an equation, we have to make the left-hand side the subject on its own. So just a variable with a coefficient of 1, so no numbers in front of the coefficient. And the right-hand side of the equation can't have any of the unknown that we're trying to solve. So here are some examples where the balancing method hasn't finished and we haven't really solved the equation. We have 2x equals 15. It's not solved because the coefficient of x is 2 and not 1. If we have negative x equals 0, it's not solved yet because we have negative x, negative 1x, rather than positive 1x. So we need to do some more operations. In the case of the third one, we have half x, so that's not even an equation yet. Let's make this equals 65. It's not solved because of this divided by 2. We would have to multiply both sides by 2 to find out what x is. In the case of the next one, we've got x on both sides. So we would need to do a number of operations to make x the subject and not have x on the right-hand side of the equation. And in the last one, we have a constant on the left-hand side. We'd have to eliminate that first. So whatever it is on the left-hand side that's there, we're trying to eliminate. If we have an x on the right-hand side, we're trying to regroup it back onto the left-hand side. Now, all of these cases would need some rearranging to solve them. We have to consider the operation, the order that we're doing it, the order we're doing the operations with, and what operations to use to eliminate the parts that are in the wrong place in our equation. So let's start with a simple case. We've used this a few times. X plus 1 equals 3. We know the answer is 2, but we're going to use balancing method to find that out. So we're trying to rearrange the equation until the equation is written x equals. So at the moment, on the left-hand side, we don't have x equals, we have x plus 1 equals, so we're trying to eliminate the plus 1. To do that, we're going to subtract 1 from both sides. And we're going to use this notation here because it's quite common. To the right of what it is that we're trying to do, we're just going to say minus 1, and that's indicating that we're going to subtract 1 from both sides. And you can see it here. Oh, you can see it here. We've subtracted 1 from the left-hand side part of the equation, and we've subtracted 1 from the right-hand side part of the equation. When we simplify, 1 minus 1 becomes 0, it becomes eliminated. 3 minus 1 becomes 2. It's all nicely simplified and we're finished. So the solution to the problem x plus 1 equals 3 is x equals 2. We can check that. 2 plus 1 is 3, 3 equals 3, the equation is true. Okay, let's try again. So here's a different one. We have 2x plus 3 equals 10. We're going to try and eliminate the plus 3 and the 2. We're going to do it in reverse BIMDAS order, so we'll do our addition and subtraction before our multiplying and dividing. You don't have to. It will still work. It's just you'll find in majority of cases your solution will have fewer steps if you do it in reverse BIMDAS order. So we're going to do the addition and subtraction stuff, then we're going to do the multiplication afterwards. So here we go. Subtract 3 from both sides. Subtract 3 from here, that will eliminate the 3 and just leave us with 2x. Subtract 3 from this side, that won't leave us 13, that will give us 7. So we better fix our equation up here. And that will be 3.5. Always good to check your solutions. Okay, so then we're going to end up with 2x equals 7. Divide both sides by 2 to eliminate this 2 here. I should probably write that in here. Eliminate the 2. in the denominator. Oh, then 2 in the coefficient, I should say. So on the left-hand side. And we do that by dividing both sides by 2. And we'll be left with x equals 3.5. Brilliant. Next one. Here's the lemonade stand problem. We have this complex equation here. What we're going to do is we're going to multiply that by -1 and that by -1, like we found out how to do with distributive law 2 videos ago. And that will leave us with 3n take 25 take 2n. 3n take 2n leaves us with n and minus 25. If we wanted to eliminate the 25, and we'll see in a minute why we do that, we add 25 to both sides. 25 minus 25 will be 0, and we're left with n equals 25. But the n's not on the left-hand side yet, so the easiest thing to do is just swap the sides, and we find out that n equals 25, as we did in the guess and check model. Now, at this point, we wouldn't know whether the profit's 24 or 26, so we'll probably make up a little table and check. There is a quite nifty way, though, of doing it without creating a table and checking whether it's 24 or 26. We can just say from the beginning that we're looking for a value greater than 0 and not 0. So, yeah, I've done that here. I've said this is how we work out the profit, and we want to know when this, the profit bit, is greater than 0. We've simplified as before to get to this statement here. When is n take 25 greater than 0? Added 25 to both sides, and found out it's when n is greater than 25. So the profit will occur at n equals 26. The only thing we have to be mindful of when we use an inequality is that if we ever multiply and divide by -1, we have to change the direction of the inequality. So instead of being greater than, it would be less than. So as long as we don't multiply and divide by -1, that's fine. It's the same with swapping the sides. If we swap the sides, we have to change the direction of the sign, and that's because to change the sides, we're actually doing some subtraction. It's not doing subtraction. We're doing subtraction and then multiplying by -1. But we don't normally go through the rigmarole of showing it. It's an interesting exercise if you want to actually go through 25 equals n and then rearrange it without just swapping them. So do it by subtracting n from both sides, subtracting 25 from both sides, then multiplying both sides by -1. That's the bit that causes the swap. Okay, let's go through and do some practice. So we start with, oh, this isn't working. Let me just plug it in. There we go. Is it working now? Oh no! Wake up! Oh, coming. Ah, there it is. You ripper. So here we go. We go 5x plus 1 equals 31. Oh, it's a bit yucky. Let's get a nice pen. Black. Erase this bit. Go back to here. Maybe I'll put some ruler lines up because I'm finding my writing is getting messy. Maybe a little smaller. Yeah, that'll do. Oh no, it's a bit too small. That one. Okay, so we start with 5x plus 1 equals 31. We are going to subtract 1 from both sides, so we'll end up with 5x equals 30. We'll divide both sides by 5, and that will end us with x equals 6. I can write the operations over here if that helps. We can add 1 to both sides, so 3x equals 9, divide both sides by 3, x equals 3. We should really test if these work. 6 5s are 30, plus 1 is 31. 3 3s are 9, take 1 is 8, correct? Here we've got one with things on both sides. I'll just put this in here. This is, what is this? This is plus 1. And this is divided by 3. So in this case, we're going to subtract 2x first. So 5x equals 60. And then we're going to divide both sides by 5 equals 12. Now, after a while, you don't have to write these on the right-hand side, so I might stop now. You're hearing me, but if you're writing it and you're trying to show the marker what you're doing, this is a good idea. So we've got 3x on both sides. We're going to add 3x to eliminate this part. So 6x equals 72. Divide both sides by 6. X equals 12 again. Add 2x to both sides. 8x plus 4 equals 20. Subtract x from, subtract 4 from both sides. 8x equals 16. Divide both sides by 2. X equals 2. I might find that these take a little bit longer than I thought. So 6x plus 3 equals 23 plus x. Subtract x from both sides. 5x plus 3 equals 23. Subtract 3 from both sides. 5x equals 20. Huh? I've done something wrong here. That doesn't make sense. Subtract x from both sides. 5x plus 3 equals 23. Subtract 3 from both sides. 5x equals 20. There we go. Divide both sides by 5. X equals 4. Looking at this one, I might use a bit more space over here. I'm trying to make the equal signs light up. Okay, so subtract 3 from both sides. 3x plus 4 equals 17. Subtract 4 from both sides. 3x equals 13. 14. It's not going to help much. 13. Subtract 4 from both sides. 13. X equals 13 on 3. The answer is a fraction. Looking to the next one. Subtract, well, we might put the x's on this side because if I subtract 5x, this is going to remain positive. So we're going to add 64 to this side, which will be 75. We're going to subtract, which will be 15. X equals 75 divided by 15. So let's see, 4 is going to be 16. 5 will be 75. So x equals 5. So 4 15s are 60, so 5 15s are 75. Same drill here. We might add the x's, put all the x's on this side and then swap them over. Oops, what happened here? This doesn't look right. 75 equals 15x. Yeah, there we go. So I swap the sides here to make it easier. 28 equals 17 plus 4x. Add x to both sides. Subtract 17 from 28. That'll be 9. No, it will be 11. X equals 11 on 4. My arithmetic is not working today. Multiply out the brown. I'm not going to multiply out the bracket. I'm just going to divide both sides by 5. That will give me x plus 2 equals 5. Subtract 3 from both sides. Subtract 2 from both sides. X equals 3. Same drill here. Divide both sides by 2. Subtract 10 from both sides. Divide both sides by 2. Divide both sides by 3. Add 5 to both sides. Divide both sides by 2. Oops. You might be thinking, how do I know that I'm making a mistake? Well, I'm automatically looking at my answer, going back to the beginning and thinking, does that make sense? Right, so divide both sides by, well, in this case, it doesn't make sense to divide them because it's not actually going to help very much. So what we're going to do this time is just multiply the brackets out. We're going to need a bit more space to solve these though. How do you know when to do what? Experience, lots of practice, having a good go at it. You're going to be using this for a lot of things. These skills will come with time. It's just important to see how fast you should be going eventually. Subtract 6 from both sides. Subtract 14x from both sides, get 6x. Add 12 to both sides. Oh, 33. x equals 33 on 6. 6 goes into, well, divide both by 3, I suppose. So that'll give you 11 on 2. Again here, no point dividing both sides, so might as well just multiply them out. Subtract 3x from both sides, so that'll give me 2x on this side. Subtract 50 from this side, that'll give me negative 38. Divide both sides by 2, swap them over, x equals negative 17. Well, no it doesn't. So x equals negative 38 on 2, half 38 is 19, negative 19. Okay, it still doesn't make sense to divide, so I'm going to multiply this one out again. 6x take 8 equals 4x plus 3. Subtract 4x from both sides, 2x take 8 equals 3. Add 8 to both sides, 2x equals 11. Divide both sides by 2, x equals 11 on 2. And there you go. That's a lot of examples that you can go over and say, well, why did he do that? And then nut your way through how it was done and why it was done, why was the order picked. Once you've done that, balancing method becomes one of the most powerful things that are in your arsenal of tools. So yeah, make sure I haven't stuffed it up down here. I have a little bit, but that's okay. All right, well, I hope that helped, and I will see you in the next one. Thanks, everyone.